The topic for Lesson 1-5 is angle relationships. You'll learn to identify and use special pairs of angles and identify perpendicular lines. When two lines intersect, four angles are formed. In some cities, more than two streets might intersect to form even more angles. All of these angles are related in special ways. Okay, for example, that looks pretty much like a right angle. That would be an acute, and that would be an obtuse, and together they make a straight line, which has a special name. Adjacent angles are two angles that lie in the same plane, have a common vertex and a common side, but no common interior points. So angles ABC and CBD are adjacent, and those are acute. These two are adjacent, and they're up. ABC is obtuse that time, CBD is acute. But if we do angle ABC and angle ABD, those are not adjacent because there's a shared interior space. And, well, this doesn't even look very promising. This ABC and BCD don't have a common vertex. So adjacent means next to. That's kind of next to, but they need the common vertex. Vertical angles are two non-adjacent angles formed by two intersecting lines. So angles AEB and CED are vertical angles, as are AED and BEC. AED here is not vertical to BEC because DE and C are non-collinear. They don't form a straight line. So to get vertical angles, we're looking for that X situation. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So angles BED and BEC form a linear pair because DC is a line. This is not a linear pair because there is no line. Name an angle pair that satisfies each condition. Okay, so for part A, we want two acute vertical angles. Okay, vertical, we're looking for that X situation, so they share a common vertex and the lines go in opposite directions. So we could do either these two 30s would work or these two 55s would work. The 30s would be angles BAC and FAE. 55s would be angles CAD and NAF. Name two adjacent angles whose sum is less than 90. Well, adjacent means next to. They share a common side and vertex. Sum is the answer when we add. So actually those angles that we marked are helpful again. I could do angle BAC and angle CAD. Their sum would be 85, as would the sum of angles NAF and angle FAE. Complementary angles are two angles whose sum measures have a sum of 90 degrees. Angle 1 and angle 2 are complementary. They obviously form a right angle, so they have to have a sum of 90. Angles PQR and XYZ are also complementary because even though they're not adjacent, they would have a sum of 90. Supplementary angles are two angles whose measures have a sum of 180 degrees. So in the diagram, angles EFH and HFG are supplementary. They're also adjacent, form a linear pair. Angles M and N are also supplementary because the sum of their measures would be 180 degrees. Find the measures of two complementary angles if one angle measures 6 degrees less than 5 times the measure of the other. Okay, we know complementary adds up to 90, so I'm just going to sketch. That's a lovely sketch. Okay, there's two complementary angles. One measures 6 degrees less than 5 times the other. So I'm going to let the other be x. So then this is going to be 6 degrees less than 5 times the other. Okay, we know that complementary angles add up to 90 degrees. So x plus my 5x minus 6 adds up to 90. So adding my like terms, 1x plus 5x is 6x. Add 6 to both sides. Divide by 6. And we get x equals 16. Okay, it doesn't just say find the measure of the smaller angle, it says find the measure of both. So that's my first angle. To get the other angle, we're going to substitute that 16 in for x in that expression. And 5 times 16 is 80, minus 6 is 74. And then if I check, I want to make sure they're complementary. So 74 plus 16 does in fact equal 90. I am happy. So my two angle measures are 16 and 74. Perpendicular lines intersect to form 4 right angles. Perpendicular lines intersect to form congruent adjacent angles because they would both be 90. Segments and rays can be perpendicular to lines or to other line segments and rays. The right angle symbol in the figure indicates that the lines are perpendicular, and the symbol looks like an upside down capital T is read perpendicular to. So this expression would be read line XZ is perpendicular to line WY. You can see there's little arrows on either side there. Find x so that line KO is perpendicular to line HM. Well, perpendicular means that has to be a right angle, so those angles are complementary, they add up to 90 degrees. So to solve, we're going to combine like terms. 3x plus 9x is 12x. Just copying down the plus 6. Subtract 6 from both sides of the equation. And divide both sides by 12. So x equals 7. Now to check, we could come back and substitute that 7 in. So we'd have 3 times 7 plus 6 plus 9 times 7, we hope equals 90. So 21 plus 6 plus 63, does it equal 90? 27 plus 63. Yep. It worked. Here's a quick list that gets us started on what can and cannot be assumed on diagrams. We can assume that all points shown are coplanar, they're on the same plane, they're on the paper. Points L, P, and Q are collinear, they're on the same line. Ray PM, ray PN, ray PO, and line LQ intersect at point P. P is between L and Q and is in the interior of angle MPO. Angles LPM and angle MPN are adjacent angles. Angles LPN and NPQ are a linear pair, and angles QPO and OPL are supplementary. You cannot assume just because it looks like it that anything is perpendicular, that anything is congruent just by appearance, and you cannot assume that segments are equal in length or congruent because they look like they are. Determine whether each statement can be assumed from the figure below. Explain. Okay, can we say that the measure of angle XAY is 90, and I want to add that degrees again. I would say, well, if one angle is 90, those lines are perpendicular, so all of those are 90, so that's a yes. And the explanation is line TY is perpendicular to line SX. Are angles TAU and UAY complementary? No. There is a relationship, but they are supplementary. They make a straight line together, add up to 180 degrees. Our angles UAX, okay, that's that guy, and UXA adjacent. No. They have a common side, but they don't share a common vertex. There are many special pairs of angles, such as adjacent angles that share a common side and vertex, vertical angles, complementary angles that add up to 90 degrees, and linear pairs or supplementary angles that add up to 180 degrees.